Welcome to qnawire.
So now we'll work on problem 104 from chapter 20. In this problem, we're told to write the reactions for the discharge and charge of a nickel-cadmium rechargeable battery. So we're given the half reactions in the next part of the problem. So here we're going to want to put the higher reduction potential as the cathode and the lower reduction potential as the anode. So we're going to have to flip that, and we can add the two reactions for part B. So in discharge, it will be the forward reaction. So discharge, we get cadmium. We need to multiply the second nickel reaction, half reaction, by 2 because there's only one electron transferred. So we have this nickel oxide hydroxide molecule plus 2 water will produce cadmium hydroxide and nickel hydroxide. So that's discharge, and charging would simply be the reverse of these reactions. So that is part A. In part B, they ask us, given the standard reduction potentials, calculate the EMF of the cell. So we're given the values of 0.49 and negative 0.76. So we calculate by subtracting the two. We have 0.49 minus 0.76 is equal to 1.25 volts. Now in part C, they ask us a typical nicad voltaic cell generates an EMF of positive 1.30 volts. Why is there a difference between this value and the one you calculated in part B? So we can see that the value which we're given is a little bit higher than the one that we calculated. And so there's a small difference here, and this here can be attributed to concentration differences. In the battery which they sell, they may increase or decrease concentration to ensure the appropriate power is supplied, but these changes, the small change in this EMF value can be attributed to just different concentration changes of the reaction, the reactants. And in part D, they ask us to calculate the equilibrium constant for the overall nicad reaction based on this typical EMF value. So we know that the relationship between E and K is E naught is equal to 0.0592 over N times the log of K. So since we're transferring 2 electrons at 0.0592 divided by 2, log K is equal to 1.25. So we solve for K by multiplying both sides by 2 over 0.0592 and taking the antilog, and when we do that we get a value of 1.70 times 10 to the 42nd power.